lesson is on sine, cosine, and tangent. If we have a right triangle, it has three sides. The longest side is called the hypotenuse. And then there are two other sides. If we define the angle theta, the side adjacent to the angle theta is called the adjacent side, or A in this case. And the side that is opposite the angle theta is called the opposite side. As we know, the sides of the triangle are related to each other in a number of different ways. The first way that they're related is by the Pythagorean theorem. And that theorem says that the hypotenuse squared is equal to the adjacent side squared plus the opposite side squared. So if we know any two of the sides, we can find the third side using this equation. We can also relate the sides of the triangle to the angle theta using three functions called the sine, the cosine, and the tangent. The sine of the angle theta is defined as the opposite side divided by the hypotenuse. The cosine of the angle theta is defined as the adjacent side divided by the hypotenuse. And the tangent of the angle theta is the opposite side divided by the adjacent side. To help us remember these, there's a pneumatic we use, and it's called so, ka, toa. And the so part is for the sine, opposite over hypotenuse. Ka is the cosine part, which is adjacent over hypotenuse. And toa is for the tangent, and it gives us the opposite over the adjacent. So those are the rules that we're using. We'll look at a couple of examples. So let's do an example. So over here, we set the hypotenuse equal to 5, and the adjacent side equal to 3, and the opposite side equal to 4. And so, using Pythagorean's theorem, it's easy to see that 5 squared is equal to 3 squared plus 4 squared. The sine of theta can be found as the opposite over hypotenuse, and so it's equal to 4 divided by 5. The cosine of theta can be found as the opposite divided by the hypotenuse, so it's equal to 3 over 5. And the tangent of theta is equal to the opposite over the adjacent, and so it's equal to 4 over 3. If we add another angle in here, we call it phi, then we can find the relationship of sine, cosine, and tangent for the angle phi just as well. And notice now for the angle phi, the opposite side is 3, and therefore the sine of phi is 3 over 5. And the adjacent side of phi is 4, so the cosine of phi is 4 over 5, and the tangent of phi would be 4 over 3. Notice that there's a relationship between the angles and their sines and cosines. So for the angle theta and the cosine of phi, these two quantities are the same. And similarly, these two quantities are the same, 3/5 and 3/5. And notice that the tangent of theta is related to the tangent of phi by the inverse. And so we just have to invert it. So if we know the sine and cosine or tangents of any of the angles, we can find it for the third angle in the triangle using these relationships. So let's look at one more example. So let's try a second example. So in this example, we know one side, the hypotenuse, and we know the angle, theta, is 30 degrees, but we don't know what the opposite side is, and we don't know what the adjacent side is. So our goal is to find those two using sines and cosines. So we know that if we take the sine of 30 degrees, it's equal to the opposite side over the hypotenuse. So it would be the opposite side over 10. So this is one equation with one unknown, and we can solve it using algebra. So if we multiply both sides of the equation by 10, we see that the 10 on the right-hand side cancel, and we get 10 times the sine of 30 degrees is equal to the value of the opposite side. Now, since all angles with an angle of 30 degrees have the same ratio of opposite to hypotenuse, we can find those in a table. Instead of going to table these days, we can look them up on your calculator. So if you plug in the sine of 30 degrees in your calculator, you'll get back 1/2. So the sine of 30 degrees is a half, and that's independent of the size of the triangle. So no matter what the sizes of A and O and the hypotenuse are, if the angle is 30 degrees, that ratio of opposite to hypotenuse is always the same, and it's always equal to 1/2. So in that case, we look it up as 1/2, and so we get 10 times 1/2, and so the opposite side has a length of 5. We can do the same sort of procedure to find the adjacent side. So we know that the cosine of 30 degrees is the adjacent side divided by the hypotenuse. And again, if we multiply both sides of that equation by 10, we get 10 times the cosine of 30 degrees is just equal to A, because the 10's cancel. And so we can get the adjacent side right away if we know the cosine of 30 degrees. Again, the cosine of 30 degrees is the same regardless of the size or dimension of the triangle. And it's given by the square root of 3/2, which is about 0.866. So in this case, we get 10 times the square root of 3/2, and we can cancel out the 2 with the 10. Write this as a 5. So we get 5 times the square root of 3 is equal to A. And again, if you use your calculator, you can find that to be equal to about 8.66. So the adjacent side is equal to about 8.66, or 5 times the square root of 3. So that's how we can use the sines and cosine functions to find the sides of an unknown side of a triangle. So let's do one example now that has an engineering application. Okay, let's do another example of an engineering application using sine, cosines, and tangents. In an electrical circuit, there are 3 types of power. There's the real power, which is the power that's absorbed by the circuit. There's the reactive power, which is the power that's actually stored inside of the circuit. And there's the apparent power, which is the combination of the absorbed power and the stored power. And that combined power is called the apparent power. And the apparent power can be found from Pythagorean's theorem. So the real power, the reactive power, and the apparent power are related by a triangle. And therefore, we can use Pythagorean's theorem to find the unknown quantity if we know any of the other 2. Additionally, usually in many cases, we're interested in the amount of real power and its ratio to the amount of apparent power. And so the ratio of the real power to the apparent power can be found from the cosine of the angle theta. So the power factor is what we call that ratio of the absorbed power over the total power, if you will, or the apparent power. And so the cosine of that angle is called the power factor. So here's our question. Suppose we know that a circuit is supplied with an apparent power of 100 and has a power factor of 0.8. And what we want to do is we want to find the amount of real power that's absorbed in the circuit. So how do we go about doing that? Well, we know 2 things, right? We know basically the cosine of the angle theta, and we know the length of the hypotenuse, and what we want to find is the adjacent side. So again, we can use the cosine to do that. The power factor is the cosine of that angle, and we know that it's the ratio of the adjacent side to the hypotenuse using SOHCAHTOA. And we know 2 of those quantities. So we know the power factor is equal to 0.8, and therefore the real power divided by 100 has got to be equal to 0.8. So some of you can do that in your head, but we can also do it by using some algebra. We multiply both sides of this equation by 100. We get 100 times 0.8. We get the real power divided by 100 times 100, and the hundreds cancel. And so we see then that the real power is equal to 80. So we can use trigonometry, or we can use sines and cosines and tangents to solve a real life engineering problem.